this 2019 paper, structured essay. So the last two papers, 18th 2018 paper, we discuss everything, right? Anything left? So question number 1, how many of you have done this? 19. And 2020 paper also I have already posted to your WhatsApp group. First I'll discuss 2019 paper. Please raise the hand those who have done 19 paper. Those who have answered this, please raise the hand. Right, very good, all of you are done. Right, well done. Okay. Question number 1, part A. Following questions are related to the elements of the second row in the periodic table. Write the symbol. Here symbol highlighted. No need to write the name. If they ask you to write the symbol, you have to write the symbol of the element within the space provided. And periodic table is given. So I think IUPAC periodic table I have already posted to your WhatsApp group. If any one of you have not got that, please let me know. This is the periodic table, so you can refer this also. Second row means these elements from second period elements, that is from sodium, from lithium to second period means lithium to neon. This one, right? Second period elements, right? Okay, you can put question part number, like when you are posting the answer, put the question number also, otherwise when reading the question, so your answer, so I'll find it difficult. So you can put Roman number 1 dash answer, Roman number 2 dash answer, like that. So right, rather than just posting the answer, Roman number 1, no, just 1 dash answer, 2 dash answer, no need to put dot even, right? Okay. Anyway, depend on your convenience, right? First one, identify the element that has highest electronegativity. So very easy. This is O level. So this is 2019 new syllabus first paper. This is the new syllabus under your syllabus first paper. New under new syllabus first paper. 2019 new syllabus first paper. Right. Identify the element that has the highest electronegativity. Disregard noble gases. I got the answer only from Ran Silvani and Seshan. Don't post the answer for the part 2. I am expecting the answer from everyone for the part 1 first. Okay, Dinetni gave the answer, Tisat gave correct, and Chaniti gave. So the answer is fluorine, capital F. Okay, I'll write the answer. Answer is fluorine, capital F. So fluorine has the, even O level students can write this. This one can get the answer easily, capital F, fluorine. Since they have asked you to write, okay, and the other advice, you have to pay more attention to the question word or the active word given in the question. Second row highlight and symbol highlight. So the symbol from the second row you have to, yeah. Sejan, you gave neon, so that is wrong. So again you have given the correct answer. Dinetmi Chaniti correct and Rana Silvani correct. Tisat also correct. Very good. Right, fluorine has the highest. So second highest, if someday they can make you upcoming papers, they can ask second highest electronic, then your answer is oxygen, right? Okay. Then number 2, can you quickly post the answer? Number 2, yes. Number 2, part 2. Right. The question is, identify the element that form monoatomic ion largest in size. Monoatomic ion. So it can be plus or minus, no? So that should be a stable ion, largest in size. That's a good question. Let's see. Most of you all gave second one. Oh, wait, second one. Sorry, second one. Identify the element that has the that has an electron of which conduct electricity. Yeah, very easy. Again, O level exam question. Electron of conduct electricity. Right. So this highest electronegativity. Answer is very good. All of you are correct. Answer is carbon. Don't write graphite. Abdur, you gave the answer graphite. So then what you have given, your answer is correct. But they ask the element. I didn't look at the question, Abdur. Identify the element. or they are asking the symbol of the element, right? So at the beginning also they ask write the symbol of the element within the space provided. So then if you write graphite, they will not give marks. They will not give marks. Understood, Abdul? Okay. So the answer will be okay. Second, you gave the answer correctly again. Very good. Answer is carbon, capital C. Right. So you are given the periodic table. Don't worry with the paper. Capital C, carbon. Then part 3. Identify the element that forms monoatomic ion. Okay. Number 3. Can you quickly post the answer? Monoatomic ion largest in size. Monoatomic ion largest in size. Yes. Monoatomic ion largest in size. Answer is right, all of you. Tisat, Chaniti, Dinetmi, Abdur, Ranzuruni. Okay, very good. All of you get the same correct answer. Very good. How to find this easily? Monoatomic ion. That means single atom, one ion, and it's largest in size. Right. Okay. I think everyone did. Everyone replied. Okay. Good. Very good. Answer is nitrogen. Very good. Excellent. All of you are correct. I thought you will was at least one of you will give wrong answer. So nitrogen. Very good. How to decide this? Radius of the anion is greater than the cation. And neutral atoms. Therefore, size of the anion with higher charge is greater. Please copy down a short note for this. This one you should know a little bit new. Something new you can learn from this. Anion is larger than the cation as well as neutral atom. Please write it. Please take a note. Please take a note. What you write now? Anion is larger than cation. Anion is larger than atom. Atom is larger than cation. So if you take sodium, magnesium, aluminium, right, silicon, phosphorus, sulfur, chlorine, or even lithium, beryllium, that means second row, boron, carbon, nitrogen, oxygen, right? So fluorine, chlorine. Now look at the screen. If you take this anion, when the charge of the anion increase, the size further increase. Anion with greater charge, anion with higher charge, anion with greater charge. Please write it. Out of anions also with the highest charge. Anion with the highest charge, having the larger in size, largest in size. So nitrogen is and the other one, the stable. It should be a stable ion. Look at the screen now. Out of this, the most stable. Now, if you take the largest anion formed by whom? Nitrogen N3 minus, oxygen O2 minus, fluorine F minus. So for the largest anion will be, they are asking here which period they have. Yeah, they are not given. Okay, anyway, they are given the second row. Second row means you have to select from lithium to fluorine one. Okay, lithium to fluorine, that group, lithium to fluorine one, this one. Therefore N3 minus will be the largest anion. Is that clear, everyone? So what happened? Anion with the highest charge will be the largest one, and nitrogen atom is smaller than. And if you take cation like Na plus, right, Na plus, what are the Li plus, sorry, Li plus, right, Li plus, and then so lithium ion, so they say I took the ones in the same group, right? If you take O2 minus, so O2 minus smaller than N3 minus, O2 minus smaller than N3 minus, and F minus smaller than uh, N O2 minus even, right? So therefore always write anion is larger than its atom as well as cation is smaller than its atom. Anion is larger than its atom and cation is smaller than its atom. If you take atom of the cation, so if you take Li and Li plus smaller than Li. Okay, so if you want to write here Li is Li plus smaller than Li as well as N is here greater than N3 minus greater than N, right? Okay, that is about so that's bit important. So is carbon can form anion C4 minus? No, Tisat C4 minus not forming. Actually carbon carbide is there sometimes, calcium carbide CaC2, but C2 minus, but C will not form C4 minus or C3 minus because it's unstable. They are asking the anion should be stable, the ion should be stable, so therefore C4 minus not available, right? Next one, I'll erase the screen, right? I'll erase the screen. Then number 4. You can post the answer on, chat. Fourth one, element that has no p electron but has stable s configuration. No p electron but has stable s configuration. No p electrons has a stable s configuration. Okay, let's see how many of you gave the correct answer. Part 4 Dinatmi, okay, Tisat, Dinatmi, Chaniti, Tisat and Ran Siluni, right? Yeah, very good. Group 1, okay, no p electron means it should belong to definitely s block. No p electrons means definitely it should belong to s block. No p electrons means it should belong to what block? S block, right? S block, that is what. And so this second period who has this stable s configuration out of lithium and beryllium, right? Lithium is S1, that is not stable. Then beryllium S2, beryllium configuration is more stable than lithium, right? So therefore the answer will be beryllium, Be, right? Very good, all of you are correct. Ran Sirun is asking, sir, what kind of ions are carbon forming? Actually that is carbide. Calcium is forming what ion? Carbide ion. Carbide ion formed by calcium carbide, CaC2. So if you take CaC2, right, calcium carbide ion. Then next one, identify the element that has highest first, very easy. So O level students also can give the answer for this 2019 new syllabus first paper. Always when they introduce new syllabus, first few years papers very easy. So I don't think you will ever find this type of easy questions in 2000 to 2010 and until about 2016-17. No. So they are more harder than this. You can, if you want, can check the past papers. Right. Quinn, can you? Everyone should give the answer for this. Don't forget from the second period. Highest first ionization is group 8 top. You can't take helium. Sishan, you gave lithium, right? So it's neon. Okay. All of you are correct now. 1, 2, 3, 4, 5. Okay. Who didn't give the answer? 1, 2, 3, 4. Oh yeah, all of you gave the correct answer. Very good. All of you are correct. Answer is neon. If they have not given the second period, then it will be helium. Next one, identify the element that forms mostly electron deficient trigonal planar. So this is a good question. Electron deficient trigonal planar. Highlight here, electron deficient trigonal planar. electron deficient trigonal planar. Right, let's see. Dinati correct, Abdur correct, Tisat correct, Chaniti correct, Transiluni correct. Very good. Who didn't post the answer? Abdur, Dinati, okay. Right. Very good. Answer is correct. Actually, electron deficient compound means we call it sometimes incomplete octet. Remember group 3 elements. Mostly group 3 elements form trigonal planar ones like BCl3, BF3, right? AlCl3. So they have only 6 electrons in the valence shell, and they are trigonal planar. But if you want, you can take beryllium chloride BeCl2 linear, but that also electron division. But here they have tell BeCl2 linear. That's why they have got trigonal planar and electron division. So then group 3 definitely. Group 3. So the answer will be boron. So now you can put marks with your red pen. Those who had done this at home alone, now you are getting prepared for the structured essay question number 1, and you will score full marks after all these papers. Then you know what type of questions you are getting. So please raise the hand those who got all correct. 24 out of 24. How many of you got 24 out of 20? All correct, full marks. Dinetmi, Tisat, Chaniti, Ran, Siluni. Abdur and Seshan, which one you got wrong? Which part? That's all right, but maybe one or two part, right? Yeah, maybe. So that also remember, yeah, graphite thing, no? Yeah, graphite thing. So that is now you know the answer, Abdur, and even Seshan, part 3, no, that is again a graphite thing. So what is the problem here? Not paying attention to the question, right? So therefore, in the exam, so not only the chemistry, you are following the instructions given, paying attention to the active word and the question word also very important. If you do that mistake for many questions, then your A can become B. Okay, so at the end, what matters for the A level, not grade, the marks, right? Okay. Anyway, I think I'm very happy about your the structured say part. Now you are doing well. So even the previous papers you had done it well, all of you. So then my advice now, don't even lose 1 mark because of the careless mistake. If you don't know that is something else, then you will not be able to write the answer. Okay. In vain if you knew the answer and did a careless mistake, right? Then next part. I'll erase the screen. Part B. Draw the most acceptable dot dash structure. Actually, dot dash structures are also called sometimes Lewis structures. Lewis dot dash structures. Because Lewis dot diagram also there. Lewis dot dash means Lewis structures, in other words. SO3F2, they have given the skeleton also. So when the skeleton is given, you can't change it. Remember that also. So throughout that all the parts, so you have to continue the same thing. Most acceptable one. Okay. Now how to post the answer for this? If you want, now there are 2 options. One is you can annotate on my screen. If you want, I'll give the permission to annotate on my screen. Number 2, you can take a photo and you can share your screen. Then I can make the correction, or else I'll write the answer. Then you can correct it with the red pen. Okay, right. Anyway, if anyone of you are willing to share the screen, let me know on chat. Then I'll give the permission, right, to share your screen. Or else if you want, can annotate it now. Even while I'm drawing, you also can annotate on one corner, no problem, no issues. But I don't know whether you're comfortable with that. If you're using the mouse, you will find it difficult. But if you have a drawing pad or writing pad, then you can connect that to your proper device and do it, right? Anyway, so how many? Now remember this very easy. Most acceptable. When it is most acceptable, oxygen is always linked. Okay, I'll go tricky one without wasting time. Sulfur, when sulfur is a central atom. Oxygen always, now see whether sulfur can have expanded octet. To make it more stable, when oxygen is linked to the central atom, oxygen always, to make it more stable, it should link with a double bond. Why? Sulfur can have up to 6 bonds. Already 4 bonds, you can make it 6 bonds like this. 6 bonds. So this oxygen also is stable. There are 2 bonds. When there are 2 bonds, when oxygen is bonded to with a double bond or 2 separate bonds, then it is more stable one. Otherwise definitely oxygen will carry a formal charge. So now this one you can see no formal charge on oxygen. Why? I made oxygen 2 bonds around each oxygen. Now I'll put the lone pairs. Fluorine cannot form more than one bond, right? Fluorine cannot form more than one bond. So I'll put 2 lone pairs on this oxygen, and then 2 lone pairs on this oxygen, and 2 lone pairs on this oxygen, right? And here we put 3 lone pairs. 3 lone pairs. Here we put 3 lone pairs. So no formal charges on any of these atoms. Please raise the hand those who had done this, those who got this correct. How many of you got this correct? Very easy. If you want, you can get the total number of electrons, subtract the bonding electron, like that. You can do it that way also if you want. Very good, all of you are correct, right? Done. So I'll erase the screen now. Then B2, I'll erase the screen. B2, the most stable. Right. The most stable Lewis dot dash structure for the molecule. This one is given below. Draw the two more resonance structures. Two more dash structures or resonance structures. Right? Unstable under the more unstable structures drawn by you. Okay. If it is unstable, you have to draw unstable. Right. Again, you are given one is given. You have to draw 2 more. Okay, I'll quickly draw the answer. If anyone of you are willing to share your screen now and not on my screen, I can give the permission. So one possibility, part 2. Now they have put a double bond between nitrogen atom. So you can have this double bond this side also. I'll mark here. You can shift this double bond to this side if you want. That is one. Then also you can have 3 bonds. 3 bonds. And this nitrogen will have then 4 bonds, but the other nitrogen 3 bonds. Or else you can have the double bond this side with oxygen. Double bond either to this side or this side. Then you can draw 2 resonance structures like this. So I'll draw I'll make this one first. This one second. Right. So I'll draw the first one, H O. Now I'm putting the double bond here. Nitrogen. Why actually convert this to double bond? Because to make it octet. Then you get N. Then NH2. There are 3 nitrogen atoms, NH2. That is one. The other one, H O N N. Here you put double bond, NH2. NH2. Right. So you get here lone pair on this. You get 2 lone pairs. You will get a lone pair, and here we will get a lone pair. to make it octet. Yeah, sure, Abdur, you can share your screen and show. Okay, wait 1 second, Abdur. I will now I will finish this and I'll give the permission to you, permission to do it. Yeah, no worry. Yeah. You have to put the loan pairs, okay? Correctly. I think you can manage now. I told you the method, right? You can shift the, you can have the double bond that side or this side. You can have the double bond either that side or this side. Yes. You get a minus charge. Look at the screen. This one you get 2 lone pairs. This one you get a plus charge oxygen. And here you get a lone pair nitrogen. And here you get 2 lone pairs, and then it carries a minus negative formal charge. Minus and here plus. And so this is unstable, no? This is unstable. And so this side you get minus. Right. So you have to, you know how to assign the formal charge, right? So you have to check the number of valence electrons for that atom, and then you have to check how many electrons allocated. If it is more, minus charge. If it is less, plus charge. If you want me to explain, please let me know. I'll explain again. So both these unstable, no? Yeah, they're asking the most unstable one. Most unstable one is this, yeah. Because oxygen carries plus most electronegative atom, oxygen carries positive formal charge, right? Oxygen is more electronegative, that carries a positive formal charge. That's why it is most unstable one due to the positive charge on oxygen. Please raise the hand those who got this correctly, both this correctly. How many of you got both this correctly? 4, 5. Run Siruni and Tisat, found it difficult, or if you want me to explain, let me know. Abdur, if you want, you can share your screen. I think you have done the same thing, ne? Okay. Okay, right. Okay. Then let's move on to the next part. Marking, they have given 4 marks for this and 4 marks for it. So 4 marks for each. They have given 4 marks for each. They have given 4 marks for this and 4 marks for this. Right. Previous and the most acceptable V structure, they have given 6 marks. 6 marks. Okay, I'll erase the screen. Part 3. Part 3. They are given based on the Lewis that given below. Okay, very easy. Very easy. I'll increase the size. Okay, you can see it clearly. Right. So in the left side one also, I'll number the atoms, then it's easy to predict the answer easily. 1, this is 2, this is 3, this is 4, and this is 5. Right. VSC PR pairs. What are VSC pairs? Sigma bonded pairs and lone pairs. VSC PR means except 5 bonds means sigma plus lone. Sigma plus lone pairs. Right. I put LP. Sigma bonding pairs and lone pairs are VSC PR pairs. I put LP. Then electron pair geometry, again you have to consider both what? Sigma plus lone pairs. Okay. So hybridization also same. The shape depends on that also. Right, now VSC PR, if you take oxygen on, you can post the answer on chat for the part. Okay, you better draw oxygen. You put all these for answers for oxygen. Right, put commas and write oxygen, everything you downwards. vertically down, you post the answer on chat. You can put commas. Oxygen equal what? This comma, this comma, this comma, this like that. Then it's easy. Right. Oxygen, you can post everything. Then it's easy. Oxygen, how many pairs? Look at the screen. I'll highlight. Oxygen 4 pairs. No? Why? 2 lone pairs and 2 sigma bonds. Ne? So I'll write here 4. I'll write here 4. 4 pairs. Electron pair geometry. Electron pair geometry. Tetrahedral. Tetrahedral. Right. Then next on the shape of the shape around oxygen will be what? Now, if everything sigma bond in pairs, then the molecular geometry and electron pair geometry same. The shape and the electron pair geometry same. If there are no lone pairs, if there's at least one lone pair, the molecular geometry, that means the shape around that atom and the electron pair geometry will be different. So the shape will be what? Angular, right? Or bent, right? You can write angular, bent, or V shape. Angular. Hybridization will be what? sp3. sp3. Right. Then next one. So all of you are correct. This angular sp3. Abdur correct. Ransirani correct. Seshan correct. Angular sp3. Okay, very good. Dinatmi correct. Chanati also correct. Right. Tisat, did you get the? Yeah, Tisat also get the same answer. Right. Very good. All of you are correct. Then now can you post the answer for this? The second one, N2. Quickly post the answer. You can put commas. N2. Can you quickly post the answer for the N2? Yes. Second one, N2. That's this one. Yes. N2 will be how many pairs around that? Only 1 5 bond, 5 bond you have to ignore. Only 3 pairs, no? Only 3. 2 sigma bonds and 1 lone pair. 2 sigma bonds and 1 lone pair. Therefore, electron pair geometry trigonal planar. Electron pair geometry will be trigonal planar. Right? Trigonal planar. And electron pair geometry trigonal planar. What about the shape? Same as before there. Since there's one lone pair, it's angular or bent or V shape. Then hybridization sp2, because 5 bond is not considered. Only 3 VSCPR. So that's correct. So let's see your answers. Tisat correct. Tisat one mistake. Molecular geometry not trigonal pyramidal, no? It's angular, right? It's angular. Trigonal pyramidal means what? There must be 3 sigma bonds. Tisat. Okay, so that you have to correct. Abdur correct. Dinatmi correct. Shaniti correct. Seshan correct, right? Okay, so understood me? Right. Everyone else, okay, all this is correct, right? Good. Now let's move on to the next one, third one. C3. Third carbon. Carbon atom label. Right. This is under new syllabus, the first paper. Right. How many pairs around that carbon? Only 2 sigma bonds. 5 bonds are not considered in C3 carbon. Only 2 sigma bonds. Therefore, only 2 VSC PR pairs. 2 VSC PR pairs. 2 VSC PR pairs. Okay. And electron pair geometry will be. Can you quickly post? I am waiting until everyone posts the answer. It's linear, right? Because only 2 sigma bonds. Now remember, since there are no lone pairs, electron pair geometry and the shape will be same. Please write that. If there are no lone pairs, so that is applicable to this. If there are no lone pairs, electron pair geometry is equal to the shape. Please write it. Put a and write it. If there are no lone pairs around, if there are no lone pairs, please put a and write. If there are no lone pairs, if there are no lone pairs, electron pair geometry if there are no lone pairs, then electron pair geometry is equal to shape. That is applicable for any other example. Please copy down this. Right. Then hybridization, SP, right? Hybridization will be SP. Okay, right. Now all of you are correct, right? Yeah, very good. Why is this on trigonal plane? That is N4, no? Okay, linear SP, linear SP is right. All of you are correct. Next one. Right. Number 4. Okay, all of you are correct. So the fourth one, N4. Can you quickly post the answer? N4. Chaniti gave the answer. Dinitmi gave. Ransiruni gave. Right. N4, there are 3 sigma bonds, no lone pairs. 3 sigma bonds, no lone pairs. Therefore, so the molecular geometry is equal to the electron pair geometry, or the shape is equal to the electron pair geometry. Therefore, it's trigonal plane. And this also is trigonal plane. And it's sp2. How many blanks are there now? There are 16 blanks. Please raise the hand those who got all 16 correct. All 16 blanks correct. The end, full marks. Right? Tisat, which one you got wrong? Okay. Right. Very good. Right. So I'll erase the screen now. Let's move on to the next one. Now they are asking based on the same, right, part 3 above. I'll quickly draw this more rightmost side, then it's easy to refer. Rightmost side, I'll draw the structure of that one. I'll quickly draw it, or else I can without erasing that part I can leave it. No, we have to write it again. Now okay, so I'll put the lone pairs around oxygen. You can post the answer for on chat, right? Number one, you can post the answer part 1 now. Because for easy reference, I put the answer rightmost side, then it's easy to explain any mistake that you have done. So I'll label the yeah 1 2 3 4 1 2 3 4 and 5. No, it's starting from here. Sorry. 1 2 3 4 5. Right. If terminal atom, so remember terminal atom, there are two answers. Either you can go for right. So if what is the answer you put? There are two possible. So either 2p or sp3, both are accepted. So if you take here 4 VSCPR pairs, then 4 VSCPR pairs, so then we take sp3. O1 also sp3. Why? Because there are 4 VSCPR pairs. That means sigma bonds plus lone pairs. Sigma bonds and lone pairs. O1 is a we wrote now this side, so it's like kind of very easy. No point of asking that again. Anyway, it's N2 will be sp2. My advice, the best thing with the pencil, you better mark this in the exam. In the exam, you can put like this. Then it's easy. You will not do any careless mistake. You can save the time taken. No need to think. No thinking time. You can straight away. You can put all this. Therefore, the best thing is what you can put here. So 2p. You can put here sp3. This one sp3. Like that you can write all this. Then it's easy, right? You can save time. You can quickly complete that without wasting time, and you don't need to not thinking time. 2p sp3 sp2 c3 will be sp and N4 will be sp2. O5 will be 2po sp3. 2po sp3. Like that you can quickly label this with a pencil or in a separate paper. Then no need to waste time again. Understood? Right, now you can quickly, so I don't need to write this, right? I wrote everything now. Now you can look at this and complete the answers. Anyway, I'll quickly write that. You can mark with a red pen those who have done this at home. You can mark with a red pen those who have done this at home. Number 3, you can write sp2. This is C3 will be SP, and again C3 will be SP, N4 will be SP2, and N4 will be SP2, O5 will be 2PO SP3. No need to write both, one is enough, either 2PO SP3. N4 will be SP2, and Cl will be either 3p/sp3. Right, is that clear? Please raise the hand, all the blanks correct. How many blanks here? 2 into 6, 12 blanks. All 12 answers correct. How many of you got all 12 correct? Very good, excellent. All of you are okay. Right, nice. Right, then next part. Identify the atomic orbitals involved in the formation of the following 5 bonds. Highlight here the formation of 5 bonds. 5 bonds in the Lewis structure. In the Lewis dot dash structure. Okay. Can you quickly post the answer on chat? 5 bond. Remember, the most simplest method, 5 bonds are formed only by 2 p orbitals. Put a stand right, everyone. So no need to actually 2p you get here, because 2p carbon also 2p, there's no like not 3p is not available. So all this p block and the second period, right? All this second period p block. Therefore, remember 5 bonds. Put a stand right. 5 bonds are formed only by 5 bonds are formed only by p atomic orbitals. 5 bonds only by p atomic orbitals. Only by unhybrid p atomic orbitals. Unhybrid p orbitals. Please write it, everyone. Hybrid orbitals will never form 5 bonds. And s orbital will never form 5 bonds. That's very important. Only by unhybrid p atomic orbitals. 5 bonds are formed only by unhybrid p atomic orbitals. Is that clear? Please copy down this in your short notebook. Take a note. Please raise down part 5. All 4 blanks got correct. Those who got all 4 blanks correct. Good. Who didn't raise the hand? Which one you went wrong? Who didn't raise the hand? Okay, right. Shall I raise this? Anyone still copying down? Done, right? Shall I raise this? You can, don't ever miss marks from this type of questions. Very easy. Actually, now you are doing 2023 A level. That means you are getting under this syllabus. 2019 first paper, 20 second paper, 21 third paper, 22 fourth paper, 20 19 20 21 22. You get the 5th paper under the syllabus, right? So gradually it's going to be a little harder, therefore, because the students, they practice about, not 2020 onwards, so even before that 1980s onwards, some students, they practice papers and come, therefore they come across hardest questions also, they practice well. So especially the revision one, I mean those who are doing the second shy, they have more time to do more revision, but the first shy students, sometimes they don't have. That's why benefit of doing this paper class from the beginning, no? on the first chapter itself. You are revising everything in the past 30 years papers. Otherwise, you will have a big competition from them. They said in the second shy and third shy with 3 A's in their hand. Sometimes 2 A's and with 2 A's and 1 B, some students are repeating again the exam to enter medical faculty. Remember, right? To enter medical faculty or engineering faculty. Some students they are targeting Moratuwa or Colombo medicine, engineering Moratuwa, like that. So sometimes if they won't get selected, so those are in Colombo, they don't want to travel to the other areas, then the other provinces, then they are sometimes repeating the second, so they take a risk. Don't forget that you have competition with this, so you are doing the exam with those people also, second shy and third shy people also. Therefore, you also should be thorough with your revision and everything, right? You need more experience, more practice, right? Then I'll erase this. Part 6. How are the double bonds oriented in the Lewis? Okay, okay. I will keep that structure. Otherwise, I have to draw it again. I'll erase the rest only. I'll keep this one and erase the rest. Right. So the question now. They ask in this how are the double bonds oriented? So this you can see the structure, right? Part 6. Part 6.1. How the double bonds oriented in the Lewis dash structure given in part 3. So the Lewis structure, now I'll highlight the Lewis structure. This is the Lewis structure. How are the double bonds oriented? Can you all pause the answer to the chat? Yeah. So what to write actually this when they ask how the double bonds are oriented means there are two double bonds, right? That I'll highlight this. These are the two double bonds. I'll highlight this again. I'll lob like this. This is one double bond and this is the other double bond. Look at the screen here. So I highlighted them red. I highlighted the two double bonds red. Double bonds oriented in the Lewis structure. So can you pause the answer? I'm waiting. Sigma bonds are linear. Okay, Abdur gave the answer and phi bonds are perpendicular. Both the double bonds but only the Abdur gave the answer. What about the others? What to write for this? So that's sometimes it's confusing. Like some of you all will be confused with this question. You might not understand what they're asking sometimes. No. Actually, here sigma bonds are linear. Sigma bonds are linear, and phi bonds are perpendicular. Or else we can write double bonds are perpendicular to each other. Double bond will be perpendicular to each other. You can see here because that is sp2, this is sp. So there are two possibles. You can write here actually when you do this, can you remember the p orbitals? I don't know whether you had done this orientation. Px, py, pz like this. Wait, I'll draw it and show you, then you'll understand. And this nitrogen. So when the form is from is pi bond, so it's sp2 hybrid orbital is like this. So let's say it's like this. So this is nitrogen, and sigma bond linear overlapping. What is this? sp. If you only can make a small sketch of this is sp. Okay, this is sp2 and this is sp. sp2 and sp linear overlapping forms a nitrogen carbon sigma bond. Nitrogen carbon sigma bond, right? And again there's one more sp in here. This side the other sp. Look at the screen. This is the other sp. Of which carbon? This carbon atom. Here C carbon. And here the nitrogen. Here the carbon. Nitrogen N. Carbon C. And this side also there's a nitrogen with sp2. So this also what happened? Sp is this one linear overlapping and then this will be like this. This is the other nitrogen. That is sp2. That is sp2. Look at the screen. So this is sp2. sp, right? So I'll highlight now this side sigma bond. I'll highlight green. sp2 and sp. This side sigma bond sp and sp2. sp and sp2. Like this. Now two sigma bonds linear, right? Two sigma bonds linear here. But when if you take 5 bonds, now there will be a 2p unhybrid orbital. This one has 2p unhybrid orbital like this. 2p unhybrid orbital there like this. So that is lateral overlapping. This 2p unhybrid orbital, I'll use a different color if I will use different color. Pink I'll use here, pink. Oh, not pink. I'll use green or so blue. I'll use blue. Okay, so there will be a 2p unhybrid orbital like this here. This also has what? sp, it has unhybrid orbital like this. So there are two unhybrid orbitals. This also has unhybrid orbital, right? So it will laterally overlap like this. So that is perpendicular. Perpendicular. So that is sigma bond, 5 bond here. 5 bond by lateral overlapping, and that lateral overlapping 2p unhybrid orbital, and this one will be perpendicular to each other. In here, right? So otherwise I can just give the answer, but you should know sigma bonds are linear, 5 bonds are perpendicular, but two double bonds are they are double bond means the other 5 bond, right? So they are perpendicular to each other. So how to write the answer? Now I'll erase this one. So how to write the answer for this now? Sigma bonds are linear, sigma linear head to head overlapping, 5 bonds lateral, so they are perpendicular. So what write now? Right here, sigma bonds are linear and 5 bonds are perpendicular. Five bonds are perpendicular. Please raise the hand, those who have written this answer before I explain. How many of you wrote this answer before I explain? Please raise the hand. None of you. Right. Next one. Are they asking give an example for similar example? So one of the best example, carbon dioxide. Carbon dioxide also what? Like this is 2 sigma bonds and 2 5 bonds like this. So in the double bond, sigma bond linear and 5 bond will be perpendicular to that. Perpendicular to that. 90 degrees angle. You might think, sir, it's there in the same line. No, carbon dioxide linear, molecule linear. I'm talking about that overlapping of the orbitals. Overlapping of the orbitals. Orientation in the space. So otherwise the molecule is linear. Molecule is linear. 180 degrees angle. Bond angle 180 degrees. Bond angle. But orientation will be different. This is about orientation. Then next one. I think that 19 mark in some system they have got this wrong. Because they have not understood the question. That's the reason. There are many other examples I can give here. Other than that, you can write even CO2. What are the other linear one? NO2 plus linear, NO2 plus linear. That I mean, you can write beryllium chloride. Beryllium chloride also linear, but you can write that. No need to draw the structure. You can just write CO2, comma, then NO2 plus. Then you can write here CN2 2 minus, CN2 2 minus, comma, N3 minus, A side ion, N3 minus, A side ion. All these are linear. This should be N3 minus means this side, N3 minus. Sodium A side, N3 minus like this. Okay. I'll erase the screen. Your example should contain more than 3 atoms. Elements in your example should be rejected if the first and second period of the element. Yeah. So this is the condition here. Example should be restricted to the first and second period of the periodic table. 52 marks. Then part C. Part C from quantum numbers. Quantum numbers. An atomic orbital described by 3 quantum numbers NL, right? Principal quantum number, asymmetrical quantum number, and magnetic quantum number, and the spin quantum number. Appropriate quantum numbers to the name of the atomic orbitals in the boxes given below. Right. So this is one point you have to. Here 3p is given. If it is 3p, principal quantum number, you can easily get it right. Directly you can go for any. You can post the answer on chat for the first 2 blanks. Put Roman number 1 and can you post the answer on chat? So L0 means S orbital. L1 means P. L2 means D. L3 means that one not it. We are not up to D. 0 1 2. If you only can go for F even. Yes, can you all post the answer on chat? Right. Very good. These are 3 1. Right. Very good. So it will be 3 and 1. Very good. All of you are correct. It's not hard. This is 3 because principal quantum number is 3. And L will be 1. Right. I'll highlight here. Here it's 3 and here it's 1. Next one, part 2, what is the answer? How to decide the orbital? So this is 3, then you write here 3. Right. You can pause the answer and chat quickly. I can see your answer. So this will be 3 here. So this is 3 to this. And what is L here 2? L2 means what? L2 means, look at here, I put L2 means D. L2 means, L equal to means is D. 3D. 3D, right? It's 3D. The next one, number 3, you are given 2s. 2s means what? N equal 2. Look at the screen, it's a different color. So again I'll go from here to here. It's 2 here. Principal quantum number 2. L will be 0 and ML also will be 0. Please raise the hand. All 6 blanks correct. 6 out of 6. How many of you got all this correct? Ransul, which one you got wrong? Ransul, all okay. All of you got okay, right? Very good. So that's very easy, right? Quantum numbers. Actually, this paper is very easy, except the previous one, the 2 parts. So shall I erase this? General finish copying down. Done. Then next part. Part 2. Arrange the say C2, right? C2. Arrange the following in the increase in order of property. Highlight here increase in order. They already have got bold letters. Increase in order. Reasons not required. Okay, can you pause the answer for the part 1? Melting point. All these are ionic compounds. All these ionic what? Yes, melting point of LIF, LII and KF. How to decide the melting point? What? Okay. Are they ionic or covalent? They are ionic compounds. They are ionic compounds. How to predict the melting point? How to predict the melting point? So what is the theory behind this? Remember, the melting point depends on, now here the cation and anion both matter. So when it comes to KF, KF has the highest one. Why? Why KF has the highest? Sorry. KF has the highest value. And out of this, which one has the lowest? LII. LII, lithium iodide. Lithium iodide. Here KF. And LIF somewhere in the middle between these two. How to explain this? So group 1 bottom potassium, group 7 top fluorine. Highest electronegativity difference you get. Here the electronegativity decrease, here electronegativity increase. This is the highest electronegativity, this is lowest electronegativity out of this. Our lowest En. Therefore, lowest and highest means what? Electronegativity difference is highest. Electronegativity difference highest between KF, between KNF. KNF, that's the reason. Second highest electronegativity, you get what? So if you take iodine, potassium and iodine, somewhere it's at the bottom. So both these having the lower electronegativity. Lithium and iodine, so it's low value. Lithium also at the top low, this also low, this also low. Group 7 lowest bottom. Group 7 lowest bottom. Group 1 also lowest bottom, but with compared to lithium, LII and LIF. LII and LIF. So the highest will be LIF out of LII and lithium iodide and lithium fluoride. Most important thing, you always go for the most, the highest and the lowest. Then you can get the other one in the middle. Always when you are given the 3 compounds like this, or 3 ions or 3 species, what you should go for the highest and the lowest one. Highest and the lowest one. What are the factors affecting the melting point? The strength of the ionic bond, or the ionic lattice, or the electronegative difference matters for the strength of the ionic bond. Don't mix up, this is the polarizability and polarization, right? Number 2, can you post the answer on chat? I think previous one, most of you Only Chaniti. Okay, very good. All of you are correct. No, KFIS, lowest LIF. Sishan, you have put LIF lowest. No? That's wrong. Isat, okay, correct. Dinetmi, correct. Right, all of you. Yeah, now the next one, Abdur and Sishan also already they have posted the answer on chat. What about the others? Part 2. Stability of these ions. The stability of these ions, yes. What is the most stable one? What is the most stable out of this? Usually nitrogen NF5. Can nitrogen form 5 bonds? Can nitrogen have 5 bonds? Remember NCl3 possible but not NF5. Remember NCl3 can or NF3 can but not NF5 because nitrogen cannot have expanded octet. Nitrogen cannot have what? Expanded octet. Therefore the least stable one NF5. Can you all please write the reason? The least stable on NF5 because nitrogen cannot have expanded octet. Nitrogen under second period element. Nitrogen cannot keep more than 8. Or not only nitrogen, second period elements cannot keep more than 8. Then the most stable one is what? NO2 minus because nitrite and HNO2, NaNO2 you have done, you have learned right in O level also chemistry. Sodium nitrite, HNO2 nitrous acid. So it's HNO2 nitrous acid, sodium nitrite, NaNO2 like that. So NO2 minus. Then in the middle you get what? In the middle you get NO2F. Sorry, NO4 3 minus. NO4 3 minus in between that. Why NO4 3 minus is like this? Nitrogen you can have like this. NO4. But they have not given the structure here. Nitrogen you can have plus 5 oxidation state you are getting here. 3 minus. There can be a plus charge also, I think. You can have plus and minus like this. So if you want, you can go for NO4 minus like this because nitrogen cannot have more than 8. Nitrogen cannot have more than 8. So they are at least the octet is completed. Then number 3, can you post the answer on chat? Bond distance. Bond distance. How to predict the bond distance? NO bond. Yes, can you quickly post the answer on chat? NOCl. NOCl3. So here also nitrogen is what? N double bond O. You can do like this. Nitrogen is a central atom. N double bond O and Cl. There will be a lone pair. Okay. Then NOCl3 you can go like this. Chlorine. You can have a dative one like this. So you can check the hybridization now. Then you can easily check the bond diagonal. So this is sp. So this is sp2. This is sp3. Look at the screen. This is sp3. Then NO2F. Look at the screen. NO2F. Are you all copying down this? So this is NOCl. This is NOCl3. Why this arrowhead here? That is to show the dative bond. Now if you can put plus and minus. Then NO2F will be like this. NO2F can go like this. So plus and minus. Nitrogen become the donor atom, oxygen become the accept atom. So that also like a dative bond. So what is the hybridization here? This will be sp2. Now they are asking which bond angle? NO. Right. So sp3, the bond length of okay, if you take sp3, so this will be like this. sp3, the bond length greater than sp2, sp2 greater than sp. sp will be the shortest. Okay, so this is, if you take the bond distance formed by the sp3 orbital, a bit longer, like the distance, length. If you take the length of the hybrid orbital, the distance. Now longest one is what? NOCl3. Why sp3? Okay, I'll give one more example for this. Look at the screen. If you take CH4, the bond angle, CH bond angle in CH4 is greater than C2H4. C2H4 ethene. Ethene, there's a double bond. C2H4 it's greater than CH bond angle in C2H2. Look at the screen now. Look at the screen. CH4, the bond CH bond angle greater, because CH4 it's like this. There are 4 bonds like this. CH4 CH bond length greater than in C2H4. So C2H4 is like this. So that's CH bond length will be less. And if you take C2H2, it's like this. That's a triple bond. Right. So you should better copy down this also parallel to this. sp3. This is sp2. And the last one sp. Is that clear? Is that clear, everyone? Therefore here the CH bond length greater than, in this one CH bond length, and it's greater than in this one CH bond length. So this is bond length or bond distance, CH. Right. So same scenario here. NOCl3 sp3 NOCl3 sp3. So I'll draw here what is NO2F. I erase that. If you want, I'll draw it again here. NO2F. Like this. Right. So this is sp2, no? sp2. There are 3 repulsion units, so PSC, PR. Now how to compare NO2F and NOCl? NOCl, both sp2. Both sp2. But here you can see in O bond, in NOCl it's lower, because, okay, I'll write the answer now. Highest will be NOCl3. Lowest will be NOCl. NOCl. because that NOCl there's a lone pair. Lone pair. This one no lone pairs. NO2F. Right. And the other one NO2F can undergo resonance also. Okay. Shall I read this? So the last one little hard, but the others is easy. No? So yeah, I think this is the only part little difficult under this question. So they have allocated only this one. They have allocated only 18 marks. 3 into 6. 3 into 6. Please raise the hand those who got all three correct. How many of you got all three correct here? I mean all three. I mean parts. Only Abduranti Sat. Chaniti, which one you got wrong? Dinati, which one you got wrong? Ransiluni, which one you got wrong? I think in upcoming papers I'll explain about this bond length, bond distance, bond angle in detail, the melting point. I think I'll pay more attention to that part if you find it difficult, because you will come across more MCQs also from this. You will get MCQs also from this. First one and the third one, Ransiluni, okay. First one and the third one. Chaniti is asking the last one, Dinati, no? Okay. Ransiluni asking, when lone pairs are greater, doesn't it mean more bond distance? When lone pairs are great. Actually, Ransiluni, what matters here, bond distance, when you take the lone pairs or repel on the bonding pairs, so the bond angle, actually lone pairs directly affect the bond angle, because when they are lone pairs, they are attracted only towards one atom, but bonding pairs attracted towards both the nucleus, not only one. That is one fact. And the other most important thing, I told you, this one can undergo like kind of hybrid thing, NO2F. NO2F, it can switch between these to the oxygen, the double bond. So then you can go for the hybrid resonance like this, straight line and dotted line, only for this one, I mean, I'm talking about this. So that is, it's like somewhat like O3, ozone. Then the bond angle, bond distance become little greater. So I don't know whether you can remember this. So double bond, bond distance, double bond distance, and this one, and single bond. Look at the screen. Double bond, it's lower than this, and this one is less than this. So that's what matters here. The resonance, when there are more resonance structures, the bond length increases. That is the other factor here. So this way, the single bond and the hybrid, this is the hybrid resonance you get here, the middle one. So one of the best example, ozone, O3. You have learned about O3? Lower, so if you get triple bond is lower than that even. Triple bond lower than that. And the other one here, if you check the oxidation number also, what? That also will influence. Right. Higher the oxidation number. Okay, I'll erase the screen now. Now that's the end of this paper. Yeah, Chaniti also, they have given a Chaniti, you asking a question. Sir, I didn't get why NO4 3 minus less than NO2. Okay. Chaniti, you are asking this one, I forgot. This one, no? NO4 3 minus and NO2 minus. The stability. Okay. Now, sorry. and the NO2 minus and NO4 3 minus. So when you draw the structure here, so you got the answer like this, NO2 highest. You are asking why NO2 the stability is greater than NO4 3 minus. That's what you asked, no? Right. Okay, let's see the structure now. NO4 3 minus. There's a positive formal charge on nitrogen. Look at the structure, Chaniti. NO2 is like this. NO2 like this. NO2 minus. When there's a plus charge on nitrogen atom, it is unstable obviously. When electronegative atom like nitrogen carries a plus charge and is less stable, right? And the other one, there's a dative bond also, and more formal charges here, more formal charges, plus there's a positive formal charge on nitrogen atom, and this one oxygen, at least one oxygen with a double bond. So if oxygen, remember, more stable arrangement is when oxygen is linked to the central atom with a double bond. That is the most stable one. Then second most stable one is with a single bond with a minus charge, right? With a minus charge, oxygen. So this nitrogen is a central atom, nitrogen is a central atom, minus charge. Then the other one, if nitrogen dative bond the other one, dative bond the other one, like this. So if you want to get here plus and minus like that. Therefore the most stable arrangement will be what? So here the nitrogen, at least one oxygen is linked with a double bond. Look at here. In this one, NO2 minus. But this one, none of the oxygen linked to the central atom with a double bond. All these carries minus, minus, minus. Plus nitrogen, there will be a plus charge. More formal charges. Is that clear, Chaniti? There are more formal charges in NO4 3 minus than in NO2 minus. NO2 minus, negative formal charge appear on most electronegative oxygen atom. Understood? Right. Okay, good that you asked. So the others also get okay. Even if you have a small doubt, please let me know. Right, I'll erase. Now let's start 2020, the latest paper. This is the last paper. Now 3rd of February they are going to start the next, so they will be getting the next paper, 2021 paper after next month. Right. So this paper, it's little difficult than 19 paper. This paper is little difficult than the 19 paper. Please raise the hand if any one of you have done this. I mean part 1 at least. Did you all have time to do this? Well, at least now you can. Okay, run Siloni done. Who else done at least part A? Only run Siloni. Okay, no problem. We have some time at least. Now, can you post the answer on chat? You can just guess the answer and reply on chat. Now just guess the answer. Then it's like kind of in the exam also you do like that. No thinking time. It's all right. You can post the answer now, because then I can finish this paper at least today, and then we can go to a next section. Because I am planning to start unit 4 behavior of gases questions and unit 5 energetic questions parallel after this, because we did enough questions for this one, general chemistry now, and I had to pay attention to the calculation part also. Right, can you quickly post the answer on chat? The first one now. Just guess the answer now. Smallest one. I told you the previous paper. Cation, when the cation become greater, larger when the charge of the cation increase, size becomes smaller. See, the smallest ionic radius. Cation smaller than anion. And cation also, the greater the charge and the smaller in size. Very easy. Please write it. What is the answer for the part 1? Yeah, very good. All of you are correct. Not Na plus session. It's Mg. It's Mg2 plus. Mg2 plus. Right. Number 2. Highest second ionization energy. It's very easy. Which one has the highest second ionization energy? Answer is. So you can see the zigzag pattern like this. Zigzag pattern like this. Look at the screen. Highest. So you have 3 elements here. Second period, carbon, nitrogen, oxygen. Carbon, nitrogen, oxygen. So I'll put here 3 elements. Here I'll put 2 elements. Then you get 2, 3, 5 plus 3, 8. So this is how you can put. Please try that. You can put 2 right ticks. Lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, neon. You can see here, out of this, highest one will be nitrogen. Remember, nitrogen ionization energy greater than oxygen. That is very important. Nitrogen, it's greater than oxygen, right? Therefore, highest will be nitrogen. Highest will be nitrogen. The next one, who can give me the answer for the part 3? 3 compounds of this, which one has the most electronegative oxygen atom? Electronegativity, I told you, when oxidation number increase, electronegativity increase. When oxidation number increase, electronegativity increase. Right? When oxidation number increases, electronegativity increases. Okay, I'm waiting. So is in the oxygen for the second one? No. Are they asking highest second? This is sorry. They asking second ionization. Yeah, sorry about that. Okay, wait. Second, I didn't see the second ionization. Highest second ionization energy. Not the first. Sorry, but that's not. They are not asking the first ionization. They are asking the second ionization energy. Then the answer will be oxygen, not nitrogen. Not nitrogen. Then is oxygen. Sorry about that. Because removal of look at the configuration. Nitrogen, S2P3, oxygen, S2P4. Right. So when it become the second ionization, then it become what? Its electron is removed what? So it's N plus ne? From N plus, so it's become S2P2. So O plus means what? S2P3. So therefore it's become P3 ne? P3 is more difficult than from P2. Right? That's the reason. Yeah. So did you all understand why oxygen the second ionization is greater than in nitrogen? Look at the configuration. Nitrogen, S2P3. Nitrogen, N become N plus. So the second ionization is removal of electron from N plus to become N2 plus electron. So oxygen also, it's O become plus, O plus to O2 plus. So the second ionization energy means this part from N plus and O plus, removal of electron. So if you write the configuration, S2P3 become S2P2 and here S2P4 become S2P3. Remember, S2P3 it's more difficult than from P3 half fill configuration. P2 and P3 matters here. P3 half fill configuration, They are in the same period. Therefore, from P3 it's more difficult than from P2. Understood? Yeah, okay, Chaniti, I corrected that, right? Yeah. Since it's second NSH, yeah, correct. Right. Sansiloni, Chaniti, so now, okay, right? I explained that. Then part 3, what is the answer? Part 3, what is the answer? 3 compounds, which one has the most electronegative oxygen atom? Shall I read the first part? If you have any question, part 1 and 2, please raise the, okay, you can, yeah, ask on chat. No issues, I'll explain again. Part 3, they ask, out of the 3 compounds, which one has the most electronegative oxygen atom? How to explain that? Yes. H2O. So hybridization matters here. Charge matters here. HOCl. And OF2. Let's see the oxidation number. Oxidation number of H2O, it's -2, right? HOCl, what is that? With respect to oxygen is +1, respect to the Cl is -1. -2. I'll mark the arrows here. Here electrons are attracted toward oxygen. Here electrons are attracted toward oxygen. Here also electrons are attracted toward oxygen. Here one electron attracted towards oxygen, and this bond also, oxygen is more electronegative than both these. With respect to chlorine and hydrogen, so oxygen is -2. Here also what happened, this become electrons are attracted away from this, so it's become +2. +2 oxygen here, oxidation number is +2. Higher oxidation number, but no charge on any of these. Charge will also will affect. Now you can easily decide OF2 has the +2 oxidation number. OF2 has +2 oxidation number. Therefore, most electronegative oxygen atom will be OF2. Is that clear? Please raise the hand those who predicted this correctly. OF2 has, oxygen has highest negativity because of this plus charge. Higher the oxidation number, not the plus charge, higher the oxidation number, higher the electronegativity. Abdur and Seshan, did you get the answer? Oxygen OF2 there, part 3. I think I couldn't check the chat. Okay, right. Abdur and Seshan. Okay, Seshan you didn't get, no? Okay, Abdur you got it. Right, okay. Okay, I'll read this. So you understood, right? So always check when they ask electronegativity of the same atom or the same element, you should better check what? Charge, oxidation number, and hybridization. What are the 3 things? Hybridization, charge, and the oxidation number. Then part 4. Part 4. Of the 3 elements, which one will liberate energy when an electron is added in the gaseous state? Beryllium, carbon and hydrogen. Out of these 3, which one will liberate energy? That means like kind of exothermic process they ask. Which one will liberate energy? That means it's kind of becoming exothermic. Heat is liberated. That means it's an attraction, not repulsion. Exothermic means there will be an attraction than repulsion. If there's an attraction, exo. If there's a repulsion, it's become endo. If there's a repulsion, it's become endo. Which one the electron will be attracted more strongly out of these three? Yes? They're asking which one will liberate energy when an electron is added. That means energy is given out. That means boron, carbon, nitrogen. Beryllium, carbon, nitrogen in the gaseous state. Some of you gave carbon. Fluorine has the highest electronegativity, so when it's bonded to oxygen, it has the highest electronegativity. Chan is asking, sir, when can't we get it simply as fluorine has the highest electronegativity, so when it is bonded with oxygen, now they are asking the electronegativity of oxygen, not the fluorine. Chani, they are asking the electronegativity of oxygen atom. If they are asking fluorine, what they are saying is correct. Directly you can go for that. Right. Okay. So this one, the answer is carbon. What matters here? The electro. Okay, look at the screen. The other most important thing you have to consider the configuration. Look at the screen here. Beryllium S2, carbon, nitrogen P3. This is the most important thing you have to consider for the part 4 when you get why the answer is carbon. They don't want to receive an electron because their configuration is compared to carbon is more stable. Therefore, actually they will repel the electron. Actually, one factor here, someday you might argue, sir, nitrogen is more electronegative, therefore it will attract the electron. Actually, rather than that here, when an electron is added, so you have to check whether there will be a repulsion from the resistance from that atom or not. Now, when it comes to carbon, is S2P2. S2P2, which one is easy to add the electron? Carbon is willing to make it P3, no? Carbon can get the electron most easily because then it will go from P2 to P3, right? It will go from P2 to P3. But this one S2 to S2, then it becomes S2P1, that is going to be unstable. P3 also it will repel the electron. It doesn't like to gain the electron. Therefore, this one more repulsion here actually. This one also there's kind of little repulsion than carbon. So out of these three, who will like to gain this electron easily? Carbon. Carbon S2P2. Is that clear, everyone? Did you get it? Carbon is willing to take the electron. It can go from P2 to P3 configuration. Any questions? Did you understand why carbon is the one which liberate energy? That means attraction. There will be attraction here. More attraction. More attraction. More attraction means what? It's like bond making. More attraction is adding an electron to an atom is same as bond making. Bond making, attraction, new kind of new interaction. Therefore, more energy is given out. But this one kind of repulsion. So that is endo, that is positive. That means more heat is more energy required to supply the electron to this, what is called P3 is not beryllium, this is nitrogen, sorry about that, this is nitrogen, this is N is P3 and nitrogen and P3. Right, then next one, part 5. Shall I read this? Did you all get it? Why carbon is the answer, everyone? Right. Then next one, part 5, can you guess the answer? Always write the part for the configuration you have to check, the outermost configuration whether it's stable or unstable. Okay, next one, part 5. Can you quickly okay, because I am waiting until you post the answer everyone, then only I can decide up to which extent I should explain. Should I explain bit in detail? If all of you are correct, then I don't need to waste much time. I don't need to give the answer in detail, right? Because as I am just checking the answers, not only to check whether you have done it correctly, to have an idea up to which extent I should explain this. Only one give the answer, right? Out of these three, which one has the highest solubility in water? Highest water solubility out of these three. Fluorine, NaF and KF, the other one KBr. So cation and anion matters here. Highest solubility. Highest. And give me the answer. Ionic bond should be broken down. Ionic bond should be broken down. Ionic bond should be broken down. So which one is the weakest one? KF and NAF little stronger, right? NAF and KF little stronger than KBr. Which one is easy to break the lattice and to dissolve in water? Remember, dissolving of ionic compound in water is endothermic process. Heat is absorbed to break down the ionic lattice. Which ionic lattice can be easily broken down and then you get, I think you have done, I don't know how many of you have done entropy? Please raise the hand those who have done entropy and energetics, like that entropy part in chapter 5. None of you know. Unit 5 not, how many of you have started unit 5? Please raise the hand. Energetics chapter 5, how many of you have started? You didn't discuss the entropy yet, right? Please raise the hand those who have done entropy part in the chapter 5, not yet. None of you. Okay, right, no problem. Only enthalpy, right? No, okay. Then I can't explain that part here. Okay, so actually what matters here, Br minus larger than Na larger than K. That's number one. Then the anion Br is greater than F. The size I am talking about. Size. So when you take the bond length, ionic bond length, what matters? The size of the atom matters. Ion. Therefore, when you take, if they have given NaBr, that will be highest here, but here we take KBr. Actually, they have given two answers. KBr also you can argue. They have got two alternative answers here. KBr you can get, or you can get NaF. Both they have accepted here. Not NaF, sorry, KF here. KBr and KF. This will be other under size, that will be other on the size here. Actually, K is greater than, wait, it's K here. Size, if you take potassium is greater than sodium. Potassium is greater than sodium. When potassium combined with Br or F, so then potassium is larger and Br will be larger than F. So then you can go for what? K and Br, then you get KBr. It's easy to dissolve. The bond length, bond distance greater. When the bond distance increase, what happens is easy to break. Bond energy is less. When bond distance increases, please copy down it if you want. When the bond distance increase, strength of the bond decrease. Please write down strength of bond decrease. When the strength of bond decrease, it's easy to break down and dissolve it, because for dissolving the ionic compound, the ionic bond or the ionic lattice should be broken down. When the bond distance increase, strength of the bond decrease. When the strength of the bond decrease, it's easy to uh, break it. So therefore KBr, when K and B are combined, because both are larger, so if you take Br and F, Br is larger. When you take Na and K, K is larger. Therefore the answer will be KBr. Please raise the hand those who got KBr here, the answer. Yeah, Abdur, you can, okay, you can pray and come. Yeah, no worries. No issue. Please raise the hand those who got KBr. With this understanding. Only few, right? So now we can see that this is difficult than the previous paper. This is little difficult than the previous paper. Okay. The answer is KBr. Has the highest water solubility. Then, but I can't give the other explanation for this, since you all have not done the, not completed the chapter 5 here. That is hydration enthalpy. That also we can talk about here. Hydration enthalpy also we can talk about here. Other than that, ionic bond dissociation enthalpy. Part 6, who can give me the answer? Part 6. Yes. Three compounds, which one has the strongest intermolecular force? That one now I am explaining. Everyone should give the answer for this. Yes. Strongest intermolecular force. Who can give me the answer? H2O2, Chaniti. Tisat, CH3F. What about the others? Only Tisat and Chaniti gave the answer. Last one. Yes. What about the others? H2O2, I will draw the structure. This OH group is there. This formaldehyde, there's no OH group in the formaldehyde. If you want, I'll draw the structure here. This is CH3F. It's like this. Now, out of this, which one is the most polar here? OH group. OH group is there. And the shape of the molecule also matters. This is H2O2. This is CH3F. And this is HCO. Formaldehyde. This is actually dipole. Both is dipole. I put DP. This also DP. So this one can have hydrogen bond. So the answer will be what? H2O2. Not CH3F, huh? CHCl3, like, not that. Strongest intermolecular force will be H2O2 because of OH group. Say water also has hydrogen bond in because of OH group, like that. The others won't be having the hydrogen bonding. If you want, you can check the electronegative difference here. 4 minus 2.5. Carbon is 2.5. Oxygen is 3.5. Hydrogen will be 2.1. What is the difference? 1.4. If you take carbon here in CF4, carbon will be carbon 2.5. For fluorine Fluorine here 4.0, carbon 2.5. So then you will get here 1.5, no? Sometimes you might argue, sir, CF bond is more polar than OH bond here. True, but there are two OH group here, but the other groups you can see here, the other group CH group, therefore there what happened, electrons are attracted towards the carbon here. Fluorine withdrawn away. Therefore, the net effect from the other atoms also matters here. CF bond is carbon 2.5, but that one will get electron from the others. Like hydrogen electrons are attracted towards carbon. But here what happened, this side also oxygen attracted towards this, so this also attracted towards oxygen. Therefore, that bond, both the OH bonds are polar. Right. So therefore, H2O2 will be these are not CH3F. These are not CH3F. Sometimes you must be considering now fluorine has high electronegativity. Therefore, no. Otherwise, if you take carbon tetrafluoride, look at the screen here. Don't look at only one bond for this. CF4. CF4 is what? That is non-polar molecule. CF bond is polar, but by looking at only one bond, you can't check the strength of intermolecular force. CF4. Look at here CF4, carbon tetrafluoride. CF4, but that is a non-polar molecule. That is one, because the shape also matters for this. The shape of the molecule also matters. Not only for the one bond. This angular, what is the shape around oxygen? Here angular. In H2O2, hydrogen peroxide. Here also what is the shape around oxygen? Angular. It's like water molecule, angular, around oxygen. And this one is tetrahedral. This is trigonal, this is formaldehyde, that is trigonal pyramidal. Sorry, trigonal planar. Formaldehyde trigonal planar, that is sp2 hybridization. sp2 hybridization. This is sp3 and that is sp3. This one is sp3, this will be sp3 oxygen and this will be sp2. Okay. Right, I'll erase the screen now. Then part B. Draw the most acceptable dot dash structure or the Lewis structure. The skeleton is given below. I told you the most possible thing is what? Can hydrogen go expanded octet? Not possible. Hydrogen cannot go expanded octet. Right? Hydrogen cannot go expanded octet. Hydrogen can have maximum 8 electrons. Now, if you want, I'll start from the basics. Let's see the total electrons in the system. Nitrogen, valence shell, 5 electron. Oxygen valence shell, 6 electron. So how many oxygen here? 3. So 6 into 3. Nitrogen, 2 nitrogen, therefore 5 into 2. Then you get the total 10 here and here 18. Then you get here 28. Minus, how many bonds here? 1, 2, 3, 4. 4 bonds. 4 bonds means what? 8. Then you get here 20 pairs. 20 electrons. 20 divided by 2. This is for the bonding. Bonding. This is for the bonds. 4 bonds. These are the total electrons. Total valence electrons for the 4 bonds, subtract 4, then you get 20. Then lone pairs will be 20 minus 2, 10 lone pairs. 10 lone pairs. How many lone pairs? 10 lone pairs. Look at the screen here. 10 lone pairs. 10 lone pairs. I've got 10 LP. Now those 10 lone pairs, first you have to distribute on the terminal atom so that they will reach octet. Look at the screen now. I'll distribute these 10 lone pairs on the central atom, terminal atom first. This one I put 3 pairs. This one I'll put 3 pairs. This one I'll put 3 pairs. How many now? 9. Only one more left. One more left. Only one more left. Wait, one more thing. 3 terminal 9. One more thing. Wait, you have to put a minus charge on this. Now there's a minus charge here. So I'll carry this one minus charge. Right. Definitely I put 6. You have to allocate for this. Then wait, before that, this nitrogen I'll put 1. This least electronegative one is this. This one I'll put 2 pairs. Why? Because nitrogen less electronegative. But you can, if you want, you can go for the resonance. You can put on oxygen also, no issues. After that, this also good. Nitrogen 10. Right. There's one mistake. Okay, wait. I have done a big mistake here. There's minus charge in here. You didn't. There's 2 minus charge. Sorry about that. There's a 2. I was checking what's happening. There's a 2 minus charge here. Sorry about that. There's a 2 minus charge. So for that you have to add 2 electrons. Sorry about that. You have to get here. Total will be. Wait. This will be 18. 18 plus for the negative charge, 2 minus charge is there. Then you add plus 2 here. Then you get 30. No, sorry. 30. Then 30 divided 30 minus 8. Then you get 22. 22 divided by 2. You get 11 pairs. 22 divided by 2, you get 11 pairs. Sorry about that. 11 pairs. 11 lone pairs. Right. So I was checking one is missing here. Right. Then okay. You can put here 2 lone pairs. Right. Is that clear now? 3 oxygen atom you distribute 9, and the remaining 2 you put one on this and the other one on this. If you only can put on this also, because the one of this nitrogen both, then the other one, then it's not octet is not completed. So this one is octet not completed. Which one octet is not completed? This one the octet is not completed. This one the octet is not completed. Then how to make it octet? You can shift the lone pair from the other side. This one the octet is not completed because only 6 electron. Therefore, how to make this octet? You can convert single bond into double bond. Single bond into double bond. Then I'll draw the structure again. Look at the screen. Oxygen N double bond O. Yeah. So this oxygen carries minus charge, and there will be 3 lone pairs. So this also 3 lone pairs with a minus charge, because minus charge anyway we have to keep, because this iron N2O3 2 minus. So this oxygen, there will be this nitrogen, there's a lone pair, and then this one double bond, and here there's a lone pair, and there are two pairs here. Is that clear? This is the correct dot dash diagram. I'll encircle this. Please raise the hand. How many of you got this? I'll highlight that pink. How many of you got this? This one. Minus charge appeared. Okay. How many of you got this? Only Seshan. What about the others? Run only got this. Abdur, Chaniti, Dinatmi, Tisat, did you get it? Did you draw? Did you try to draw this before I explain? Or did you understand this? This is the one. Right. Is that clear? Okay. Shall I move to the next one? If you have any doubt, please tell me. So I distributed the 11 lone pairs. 11 lone pairs first distributed on the most electronegative oxygen. Then 9 lone pairs go on for the oxygen. The remaining 2 on nitrogen atom. 1 for each. So then this nitrogen octet has not reached. Therefore, I shift the lone pair from oxygen to make it octet. Right? First you have to do this, then you go for this, then you go for this step. Shall I move to the next one? Any doubt? Any more doubts about this? Did you all understand this? Okay. Chaniti okay, Tisat okay, right. Abdur, did you get it now? Shall I erase this? Okay. I'll erase. Number 2. Draw. Okay, so you asked draw 2 more. Okay, I'll leave this one and erase the rest. You asked to draw 3 more resonance structures for this, and you had to name mention whether it's stable or unstable. So look at the screen now. I will go for there. You asked to draw 3 more. 3 more resonance structures of this. 3 more resonance structures of this. Then you can draw like this. You can have this double bond this side also. To make nitrogen octet, what is the next possibility? I'll draw the other possibilities here. One possibility you can. The other possibility, look at the screen. You can have, now this nitrogen has not reached octet. This nitrogen has not reached octet. Then you can shift the one from here to here. That is one. That is one. Or you can have this double bond, oxygen double bond. You can have from this side. Instead of this, you can, okay, I'll put with the blue arrows. So you can have the double bond here. That is second one. Or else you can make the double bond there. Here. So instead of making the double bond here, you can, these are the 3 things. I'll draw the red one. Okay, I'll put different arrow for this one. I'll use say orange. That is number 3. One at a time. I'll put the red one first, right, number 1. Number 1 without doing the others, without doing anything else. So I'll make this nitrogen. The problem is octet has not reached. So then, because I put the double bond here, this one, the initial one I did like this way. I used the green one for this. This is what I did. This one, there's a lone pair again. Lone pair is not there. Right. So initial one I'll use green. So this is how I got the initial one like this. That's how you get the double bond here. Now instead of that, so that one is done. Green one is done. So I'll go for the red and blue and the orange one. No need to draw even, you can see the rest is same. So I'll make the oxygen double bond here. Nitrogen. This oxygen is there. In the lone pair. Nitrogen and oxygen. So double bond is formed from this side. But that is bit unstable. Why? There will be a plus charge. So then this one I put distribute both this. I'll make this one octet. And this one then incomplete octet. So there will be a plus charge on this, no? There will be a minus charge on this. And there will be minus charge on this. There will be more formal charges, therefore it's unstable. That is the red one. Oh, wait, that is the blue one, sorry. That's the blue one. Then next one, the red one I'll write separately. I'll draw that in the middle. This is for the second one. Then first one, oxygen, nitrogen, nitrogen, oxygen. So yeah, you make the double bond here. Then there will be a lone pair here. Minus. Whenever oxygen is linked with a single bond, oxygen carries a minus charge. Whenever oxygen is linked with a single bond, oxygen carries minus charge. Whenever oxygen is linked to the center atom with a double bond, it won't carry any part. Yeah. So this one there's a plus charge here. Third one, the other oxygen will make the double bond here, in double bond here. And there will be a plus charge on this. Okay. So actually what has happened here, one can now remember I can distribute this. I told you that nitrogen thing. There are two nitrogen, and after putting the 9 lone pairs, so look at the screen everyone. After putting out of 11 lone pairs, you can distribute 9 lone pairs around the 3 oxygen. Around 3 oxygen you can distribute 9 lone pairs out of 11 lone pairs. So how many lone pairs left after distributing these 9? Look at the screen now. I put a cage around this. This is very important. Then 2 more pairs left. Either you can put both the pairs on this. Then you can get this one, and it's like this one and this one. Or else you can distribute one lone pair on one nitrogen, the other lone pair on the other nitrogen. Like that's what I did in the part one. Right. So in case of this one, if you distribute both the lone pairs on that nitrogen, then you can shift the lone pair from this side to make it octet. That's what has happened here. This side you will shift the lone pair from this side to make it octet. Then you get this. Or else you can shift the lone pair to make it octet. You shift from this side to make it this, because the others octet reach, no? Then the orange one, I can shift the lone pair either this, or you can shift from this side. That's a double bond. Yeah, you can shift from this side to make it octet. That's how you get here number 1. Here you get this one, the pink one, the yellow one, the blue one, and this is the pink one. Right? Did you get it? Right. Because only that nitrogen is octet, it's not rich. To make it octet, you can shift the lone pair from either side, either this oxygen or that oxygen. Is that clear? Or else the other one, you can shift the lone pair from this side. Look at, I'll put one more arrowhead here, green one. You can shift the lone pair from this side here. Is that clear? That is the, I'll highlight that red one. So the green here, this one. Can you? That's the green one. Okay. So you have this nitrogen is not reach octet. I put a question mark here. Octet is not reach. You can make the octet by 3 different methods. I'll put 1, 2, 3 now. Look at the screen. Okay, forget about this. This is the most stable one. Most stable one, we'll forget about that. Right. Is that clear? Any questions? Any question? Did you all get it? Or do I, if you want me to explain, tell me. If you want me to explain again, please tell me. Right. Okay, Sijan got it. What about the others? Did you all get it? Huh? Okay. So I'll, shall I erase this? Right. If you want, you can take a screenshot, because I highlighted, because so that like I put an arrow here, lone pair is shifted from this oxygen, you get the orange one, the last one. Then the blue one, look at here, blue arrow. So lone pair shifted from here, make it octet, you get the blue one. Green one, green, look at the green arrow. You shift the lone pair from this side, you get the green one, like that, right? Okay. Because later when you study this again, okay, I'll erase the screen. If you want, you can take a screenshot, right? Then next one, part 3. Now they ask, it's very easy. They have given the structure, so I'll quickly label 1, 2, 3, 4 here. This is 1, this is 2, this is 3, this is 4, right? So you get here VSC PR pairs around the atom. In one atom, how many VSC PR pairs? 3, right? Then we'll go down, and if you want, you can post the answer on chat. No lone pairs, therefore trigonal planar. This one also what? Trigonal plane. Then this is sp2, right? So then here you get 3 here. This one trigonal plane. Here angular. And here you get sp2. Is that clear, everyone? Very easy, because similar question we have done before, right? No need to worry about this. So this is N2 here, and N1 I'll highlight green. This is N1, and next one is O3. O3, you can post the answer on chat. I'll highlight blue. O3. Total pair. So it's this one. Everyone should target full marks, because this is one of the very easier one. So here you get 4 tetrahedral, and then you get shape will be angular, and hybridization sp3. C4, I'll use pink. C4 pink. How many? C4. So it's 2, then it's linear. It's linear, and here also it's linear, and here it's sp. Right. Please raise the hand those who got all 12 blanks. So 12, not 12, no, 16 blanks. 16 out of 16. They have got 1 mark for each blank. LL marking, they have given 1 mark for each blank. 16 out of 16. Please raise the hand. Ransilu and Tisat, which one you went wrong? Ransilu and Tisat, did you get everything correct, or which one you went wrong? Right. Okay. Shall I erase this? Done, right? If you are still copying down, please let me know, or else it's not hard, it's easy. Next one. Identify the atomic orbital. Okay. Okay, we'll keep the same structure, otherwise we have to, I had to draw it again, no? Okay. This part also very easy. What's the time now? We have to, I'll finish this and stop. 7:30. Okay, look at the screen. I'll quickly draw the structure here. Then it's easy for, otherwise you will again, you have to waste time on that. Chlorine. I'll quickly draw it leftmost side. Chlorine, nitrogen, oxygen, Cn, oxygen and Cn. Right. So chlorine you get 3 pairs, nitrogen plus charge. Here you get oxygen 3 pairs. This nitrogen you get 1 pair. This oxygen you get 2 pairs. Carbon, okay. Now they have labeled this 1, 2, 3, 4 like this. One, 2, 3, 4. Right. Look at the screen. So based on this, you have to give the answer. My advice, look at the green one. I highlighted that green. Now this is given. I'll quickly label the hybridization of each. I'll label, then it's easy. Then it's easy. So N1, N2, N3, N4 they have asked now, and there's one nitrogen without labeling. Cl. So Cl, what is this? So I'll put an arrow. Cl, what is the hybridization? Yes. They haven't asked that. Oh, they have asked. So you can write here 3p. 3p because it's third period. 3po sp3. This one you can put how many sigma bonds? 3 sigma bonds, no lone pairs, therefore sp2. After that you can quickly finish all the blanks. So this one how many? Then no, you will not do careless mistakes. So my advice, with the pencil or rough paper you do like this, then after that fill. Otherwise, like from one by one you don't need to think. No, you will not do any careless mistakes. You can quickly do it and fill within 1 minute. You can complete the blanks. N2 3 VSCPRs, therefore you get sp2. sp2 sp2. Then oxygen O3 you get sp3. Then carbon C4. So it's sp because only 2 sigma bonds. Sp. It's sp. Right. Now we see the nitrogen. This nitrogen will be what? It's 2p. 2p. Now I will quickly fill the blanks. You can finish. Even I don't tell the answer now. Most of you have posted the correct answer. Very good. Most of you have posted. So this one you can go for. But don't do careless mistake. Just because of easy ones, you will, most students they do the careless mistake and they will not get full marks. So this is sp2. Look at the screen and check with if you had those who have got the printout or those who have done this. You can mark with the red pen, or else you can copy down the answer separately and you can do it again later. So N1 and sp2, N2 will be sp2, sp3, O3 will be sp3, this will be sp, C4 will be sp, and 2p OSP. Right, there will be a lone pair of this nitrogen, right? Please raise the hand those who got all 6 blanks correct. That means there are 2 into 6, 12 blanks. 12 out of 12. Please raise the hand. All 12 correct. Transilvanian, which one you went wrong? This part. 1 into 12, 12 marks. Tisat and Transil, did you get everything correct or which one you got wrong? Definitely maybe a careless mistake because it's not a hard one. Next one also is very easy. 5 bond. I told you the short method. 5 bonds are formed by 2PO, 3PO, 4PO, whatever, only P. Since nitrogen and carbon, all this belong to the second period, therefore 2P, 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 all this 2P, 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 2P. Why? 5 bonds. 5 bonds form only by 2P, I mean it can be 3PO, even 1P is not there. 3PO for 2P. If it is second period 2P, if it is third period 3P. Very easy. Is that clear everyone? Please raise the hand those who got part 5 everything correct. There are 6 blanks, 6 out of 6. Right, very good. Transilvanian Tisat, okay, right, good, okay, right. Because Transilvanian you got everything correct, right? Because I didn't see you raising the hand. Okay. Tisat also got correct, right? So this is the latest paper. This is last year A-level paper, 2020 A-level paper. Last year is like 2020 batch. Now your exam also, I don't know, sometime they'll have to postpone, right? Okay, then it's almost 7:40 now, no? Yeah, almost 7:40. I did extra 10 minutes also. Now, next week, please raise the hand those who have finished. Those who have finished unit 4 behavior of gases. Then I can start revision next week. How many of you have finished behavior of gases? Abdur and Ransiluni, did you have you started behavior of gases, Ransiluni? Because everyone else done. And Abdur, shall I start next week revision of that? Shall I post the paper, the revision paper for that? Ransiluni, which one? Have you started Ransiluni? Still in the unit 3? Okay. Then what to do? Anyway, the remaining part of this paper I'll discuss next. That's a small part today, no time, because I'll explain the parts 6, 7 and part 6, 7 and then part C. Part C I'll explain next day. Part C, right? Part C, and this one, the bond angle, also explain a bit. That part it will take about nearly 10-15 minutes, and then next week I'll do that. But now you have not done this, so please complete this. Part C, please complete because you have time in homework. This one for homework, part C, the 2020 paper. And next week then I'll do some calculation work. But I had done the calculation earlier also. It's more like the chemical calculation. Shall I discuss some MCQs or structure the same? And the bonding if you want. Okay, right. Okay, Ransiluni, unit 3 also you need, no? Yeah, from past papers and model papers. So yeah, I have some questions also, Chaniti. Yeah, both. But I prefer the first round. We'll do all the past papers. Then after that we can go for the prototype and model papers and support center papers. Right. Okay then. So Ransil, when you are done, please let me know, because anyway I want to start that soon, because physical chemistry is hard. More calculation part is there in the both unit 4 and unit 5. Right. Or else okay, then next month, no, so the next class first of no 2nd February, no, January, today is 26th, yeah, next class 2nd February 2nd, yeah, February 2nd. So then I'll post it. So this paper remaining questions please complete, then I'll post one more paper, right? Okay, then we'll stop for today. Good night and God bless you.